Hello, I want to welcome you to this section of the class. Again, we will continue with our module 4, and today we'll be talking about something different, something very interesting. What are we going to talk about? We'll be talking about, of course, ionic compounds. That is what we're going to be talking about today, ionic compounds. All right, so let's quickly take it off. As usual, I start my videos with a motivational quote. It has been so customary for me. So it says, self-doubt is the genius killer. And this was said by Robin Sharma. I'm not going to say much about it, but it's something you can ponder about. What are the learning objectives? Today, I want to achieve 3 things in this recording. Number 1, we're going to understand how ionic bonds are made. How are they formed? What are the processes involved? 2, we can, after doing that, we will predict the ions that are formed when ionic compounds are made. We can predict these ions from the understanding of how they are formed. And lastly, we will now know how to write the formula unit. Of course, the formula of any ionic compound is called the formula unit. So we're going to know how to write the formula unit from the ions of ionic compounds. Let's take it off immediately. Ionic bond formation. Ionic bonds are formed between simple ions. Remember, simple ions are formed from group 1 to 7 elements that we call them earlier. Remember, we call them the representative element. From group 1A to group 7A. The 8A do not go into reaction. We call them representative element. This element reacts in ways to achieve the octet rule. Of course, every reaction, the objective of every reaction, or when any bond is formed, is for those atoms involved to achieve the octet rule. Either 2 things, that by sharing or by loss or gain of electron. We're not going to go to sharing now because that is a covalent compound. We're talking about first the ionic ones. This is purely based on loss or gain of electrons between the 2 atoms involved. And again, remember earlier we said that ionic compounds are formed between a metal and a non-metal. The metal is the guy that loses the electron, the non-metal accepts it, and then both of them achieve their individual octet rules. Yes, so again, what I have in my note said when representative metals atoms lose electrons, and those electrons are gained by representative non-metals. Now, both of them form noble gas configuration. Of course, both of these guys will form, both of those ions will form the noble gas configurations. However, those ions, now if we have an example here, now if lithium forms an ion, lithium is in group 1, it's going to be L+, and then fluorine is in group 7, is going to only gain 1 electron to become this, F-. Now, if both of these guys come together, there is an intrinsic attractive bond between these 2. That attractive bond is actually what we call the ionic bond. That is a very strong electrostatic attraction. So that electrostatic attraction or electrostatic force or attractive force is what we call ionic bond. And in fact, it is the strongest of all types of bond. Now, what is actually happening? What is happening here is that, like we said earlier in the previous chapter when we looked at formation of simple ions, is that the metal loses electrons. So let me show you what is happening now. Now, if I do a simple electronic configuration of lithium. Lithium initially, I'm going to try to use maximize my space here. Lithium initially has 3 electrons. So this is the innermost shell. The innermost shell contains 2 electrons, and the outermost shell contains only 1 electron. Of course, lithium is number 3, so it should have 3 electrons. Now, this is lithium. If lithium is combining with another one, also has 2 shells, fluorine, the inner one will always have 2 electrons, and the outer one we have like it remaining 7. Fluorine is number 7, so we're going to have 1, 2, 3, 4, 5, 6. Let's say this is 7. This is the 7th electron. So this, we assume that these are electronic configuration of lithium. Remember, this is lithium atom. It has everything, has not lost anything, and this is fluorine atom. Now, when these two combines together, what is happening here? Now, I'm going to use a different color. What is happening here is that this outermost electron is being lost by lithium to become helium, which is the closest noble gas to itself, because helium has 2 electrons. So helium, remember, we said lithium and beryllium look like helium, whereas the rest of them is going to look like other noble gases from neon downwards. Now, what it means simply means is that lithium ion is formed, and a lithium ion is going to have, if I put an arrow here, it's going to have just one shell because it has lost the only electron in the outermost shell, and it now has only 2 electrons. So this is what we call the lithium ion. Whereas this one now will now form, again, it's not losing any shell. Remember, when these guys gain electron, they're not losing any shell. What happens is that they have more electrons in their shell. Now look at what is happening here. There are 2 electrons already here. There's an electron here. There's an electron here. Now, we have 2 here already. It has one here originally, and then it now gains another one to become 8. So what it means is that the inside is 2 completely filled, the outside is filled, is 8 completely filled. So this becomes the fluoride ion. Now, these two things have strong attraction between themselves. A full positive charge and a full negative charge attract them. And whatever we form here is what we call ionic bond. That ionic bond, and such compounds that have this type of bonding, we call such compounds ionic compound. And that is a brief animation of how ionic compounds are formed. Now, so typically what is happening between a metal and non-metal in ionic compound is typically just the transfer of electron. Yes, that's exactly what is happening. Now, remember earlier when we wrote the Lewis structure, we said if lithium has only 1 electron in the outermost shell, it's going to lose that electron to become lithium plus. Remember, if we're writing the electron transfer process, we tend to put the electron after the arrow to the right side in metal. So it has lost 1 electron. Now, where does this 1 electron go? I'm going to show you. This 1 electron is not going to be floating. It's going to be going to the non-metal, which accepts it. Now, this is chlorine. Chlorine, of course, if you write the Lewis structure, chlorine has 7 electrons in its outermost shell. So it's missing 1 here to be 8. So what's it going to do? It's going to gain that 1 electron. So that 1 electron here is actually what it gains. When it gains this 1 electron that is lost by this guy, what does it form? It forms chloride ion. So in principle, look at what happens here. It forms, remember, it has 1 here already, plus another one that it gains, and this becomes the chloride ion. Or most times, we usually write it this way. Anyways, we don't usually show those electrons, but this is actually what is going on here. So this is a typical electron transfer process. And how do we determine the number of electrons that could be lost or gained? Remember, that is what we talked about in the previous lecture, just before this one. But again, just to let you know that, we're going to use the groups to know that. Group 7 element, chlorine is in group 7, is going to form a charge of -1 because you just have to get 1 electron to become like argon. The same thing with lithium. Lithium is in group 1. You just have to lose 1 electron it has to look like helium, which have just 2 electrons. So, typical process that leads to the formation of ionic compound is just a simple electron transfer process. Now, let's go to our problem immediately without wasting time. It says, use the periodic table to predict the ions that are formed by the flowing element and write an equation to represent that electron transfer process. Now, the first thing we're going to do here, is to first of all look at the periodic table. Your periodic table will always be given to you. So if you look at your periodic table, potassium is in group 1. Let's see that is in group 1. And we know that every group 1 is going to lose 1 electron because the number of electrons it loses for metals represent their groups. So if I'm going to write the Lewis structure, it is 1 dot. Now it's going to lose this electron and become 1 plus 1 electron. So this is the electron transfer process. Remember, it is this 1 electron that it's going to give to the non-metal, which now forms the anion. Of course, let's go to the second one. Magnesium again is in group 2. It has to be 2 electrons in each outermost shell. And it's going to lose these 2 electrons to become 2 plus, and of course 2 electron is lost. Now let's take that. This is a non-metal now. Remember, non-metals are going to gain. This is in group what? In group 3. Nitrogen is in group 5A. So this is nitrogen group 5A. In group 5A, what that simply means is that the non-metals will have to do what? Gain. So how many will it gain to look like neon? It has to gain 1. If you count it this way, okay, let me show you. It has to gain 1, 2, and 3. So that is why the charge is usually 3 minus. Let me take that away immediately. All right. So what will it be? So let me quickly do that. It's going to be, so first of all, it has how many dots? Remember again, I'm going to put the 4 dot, which is 4. I'm now going to make this one what? 5. It is not losing. If you are losing, we're going to put the electron to the right side, but it's gaining, so we're going to do a plus 3 electrons. It has to gain to become, and now we're going to put electrons all around it into 8, and then you're going to put 3 minus. At times you can put bracket, you don't have to, but the shortcut is usually written as 3 minus. So this is how we do some of this problem. We're going to follow that same scheme in solving the rest of this problem as well. Selenium, again, let's look at it. Selenium is found here, and this is group what? Group 6. Group 6A, that's where they are. This is group 6A. And group 6A, guys, will have to accept only 2 electrons to look like, particularly in this shell, they will accept 2 electrons to look like kryptonium. So, krypton. So, what is it going to be? 2 electrons. So, we're going to write the electronic configuration. It's going to be selenium. We have 1, 2, 3, 4, 5, and 6. So, it's going to accept 2 electrons to become selenium. 1, 2, 3, 4, 5, 6, 7, 8 selenium ion. So this is what it's going to look like, or shortcut we write this. At the long run, we'll stop putting the dots, but I just want you to understand the mechanics of what is actually happening here. Bromine again is in group 7. Of course, let's look at it. It's in group 7 here. Group 7, what it means, you just have to get only 1. If you put the dot, you're going to have 7 dots around it. It's going to accept 1 electron to become the bromide ion. And again, you have to surround it by exactly, remember, apart from lithium and hydrogen, the rest of them must have to have 8 electrons in the outermost shell. So this is going to be this, or of course we write it this way as Br minus. Aluminum, on the other hand, in group 3, let's look at it. Aluminum is in group 3 and is a metal. A metal has to do what? Lose. So what it means is in group 3, you have 3 dots around it, and it's going to lose. We're going to put the electron to the right, and it's going to be Al 3 plus. The remaining electron has lost it, becomes charged, and of course, this is the 3 electrons that goes to a non-metal that it is coming in contact with. So this is how we show this electronic transfer process. So always feel free to pause this video, go back and do this, and come back to it. All right, ionic compound. Now, of course, I said it earlier, substances that result when these ionic bonds are formed is what we call ionic compound. Of course, this compound involves the cation, the positive ion, and the negative ion. Of course, the negative ion is called the cation, and the positive ion is called the anion. Now, there are 2 main types we're going to be looking at. Now, the binary ionic compound only contains 2 elements. Of course, every ionic compound must contain a metal. Of course, that one we don't negotiate it. For you to know an ionic compound, there must be a metal in it. So, you must have a metal, a non-metal, and a non-metal, or you can be a metalloid. And then ternary ionic compound are those of them that contain more than 2 elements. They contain more than 2 elements. We call them ternary. So what it means is that they usually contain a metal and polyatomic ions. Polyatomic ions are those ions that contain more than 1 element. Contain more than 1 element. They are still charged entities, but they contain more than 1 element, and that is what we call them polyatomic ion. So now, what are the characteristics of ionic compound? Now, ionic compounds are ionic bonds is one of the strongest bonds, and because of that, it is very difficult to actually break those crystal lattice. And because of that, they have very high boiling and melting point. Now, because they are very ionic, most of them interact with water, and they are very soluble in water. And not just that, they are soluble in water, because they have those 2 opposite sides that can carry electricity. They remain good conductors of both heat and electricity. So these are the characteristics of ionic compound. The next thing we need to talk about how do we now write the formula unit of ionic compound? Now, writing the formula unit has a simple basic idea. The idea is to balance out the positive and the negative charges. They have to balance out to become zero, electrically neutral. Now, whenever a compound is formed, a compound is electrically neutral, except it is charged entity. So what it means is that the number of positive charge must cancel the number of negative charge to become equal to zero. And there are many ways we can do this. One of those ways is what I call the crisscross method or the balancing of charges method. Now, these two methods, I made them up. They don't really mean a lot, but the basic idea is to make sure that these charges cancel out themselves. But I'm going to show you two ways I use. So I'm going to do an example with how to write the formula unit using these two methods I said. If I'm going to use crisscross method, simply means these ions, these monatomic ions will exchange their ions, the magnitude of their ions, and not the charge, and not the charge as negative or positive, just the magnitude, the number. So what does that mean? Now let's look. Magnesium is in group 2, so it's going to have a charge of magnesium, going to be 2+. Fluorine is in group 7. It's a non-metal. It's going to accept 1 electron, so the charge is going to be F-. What are we going to do? In crisscross method, what you simply do is to transfer these charges. So what that simply means is that this is 1, this is 2. So I'm not looking at the charges now. I'm looking at the magnitude of those numbers. If this is 1- and this is 1+, this one is going to go to magnesium and become a subscript. This 2 is going to go to fluorine and become a subscript. So what do I have at the end of the day? What I have at the end of the day is that I form a compound that becomes, okay, no, this doesn't look clean. Let me make it, there's a way I usually draw this that makes it cleaner. Okay, so I'm going to say this, we go to become a subscript. Now, this now, we go to this and become a subscript. So they transfer the magnitude of those charges. So what that means is that I'm going to form a compound that will have magnesium is supposed to be 1, but you don't usually write it, and fluorine is going to be 2. Of course, you don't put the 1, so this is going to be MgF2 becomes the formula. This is magnesium fluoride, and this becomes the formula of this compound. This is magnesium fluoride. Oh, wait, let me write that. Magnesium doesn't looks like it is sick. I'm going to make it fine. So this is going to be magnesium F2. This becomes the formula of this compound, because you cannot add 1 to it. Adding 1 to it is wrong. It makes it wrong. So you have to remove it. You cannot add the 1. So this is what we call the crisscross method. This is my first method that I showed you. It's called the crisscross. That's wrong. The crisscross method. Now, let me go to the other one. The balancing of ion. Now, in going to the balancing of ion, let me go to my pen. In balancing of ion, what do? I'm just going to balance the ion and assume I'm doing a simple algebra. That's what I'm doing here. I'm balancing the charges. So now I'm going to first of all write out what I have. So here, this is in group 2, so it's going to have a charge of +2. This is fluorine. Fluorine has a charge of -1. Now, I'm going to try to write. Now, so I have to, but how do I balance this charge? There is one of these, but there are 2+ here. For me to balance this, I'm going to make this 2. What do? I'm going to make the 2 of these. So that if I make 2 of these, it simply means -1 plus -1 will give me what? -2. And -2 will balance +2. -2 +2 is going to give you 0. Therefore, this is balanced. So what it means, if I have 1 of these and 2 of these, the formula is going to be 1 magnesium again here, and how many F2? 2 F2. Again, this becomes the formula. So you're free to use any one you want. These things, I just made them up, but to make it very understandable for the students to use them easily. So we're not going to go straight into our problems. He said, what are the formula units for the ionic compound formed between the pair of the following compound? Again, use the periodic table. Magnesium is in group 1, is going to be 1+, because you have to know that. Chlorine is in group 7. Group 7 will have a -1. It's going to be chloride minus. So what do? Since the charges are equal, if you transfer 1 is 1. Whenever the charges are balanced, I just advise students bring it down. So just bring it down immediately. It's going to be KCl because the charges are equal. Now, for this one, let's see. Sodium is going to be 1 plus, is in group 1. Again, remember that. Now, phosphorus rather, is in group 5. So group 5, remember, for the group 5 guys, they're going to just be 3 minus. So phosphorus is going to be P. Oh, that's wrong. That's wrong. It's going to be P3 minus. Now we transfer the charges. Again, if you transfer the charges, now this 3 is going to go here as a superscript, and this 1 is going to go here. So what would that give you? That simply give you Na will become 3. Since this is 1, you don't need to put it. So this becomes the formula of that compound. Again, we go for this one. Magnesium, again, we talked about it earlier. Magnesium is here. It's in group 2. So it's going to be Mg2 plus. Let me put it up here. It's going to be Mg2 plus. And then nitrogen is in group 5. Is above phosphorus here. It's going to be 3 minus. It's going to be N3 minus. So again, we transfer this to this. And we transfer this to this. What does that become? It becomes magnesium. It's going to become 3. Take the 3 from nitrogen. And nitrogen is going to take the 2 from this. And this is the formula of the compound formed from the ions of those 2 compounds. Again, the next one. What is the formula you need for the following? Same question. Calcium again is in group 2. You can look at it. Group 2 is going to be 2 plus. Selenium is in group 6. Look at selenium. The group 6 guys who non-metals will gain only 2. So it's going to be selenium will be 2 minus. And if you put them together, they're just going to stay because they're equal. You're going to have this. Now again, let's do aluminum. So aluminum is, let's look at the aluminum is in group 3. It's going to be 3 plus. It's a metal. That's where the metal stops. Then oxygen. Again, let's look at oxygen. Oxygen is in group 6. 6, they're going to be 2 minus. They will gain 2. So when you swap these ions, again, I'm not going to show you that. Just know it's going to give you aluminum. We take the 2 from this. We take the 2 from oxygen. And oxygen is going to take the 3 from aluminum. You have Al2O3. This becomes the form. Again, we do this. For this, we say sodium. So let me use the balancing to do this. Let's use the balancing. I've not used it for some time. So this is going to be sodium, of course, is 1 plus. Let me give myself some space. Okay, sodium is 1 plus because it's in group 1. Remember that. Phosphorus itself is group 5, so it's going to be 3 minus. So this will be P 3 minus. No, this is P. No, I'm going to write that. P 3 minus. Now, if I'm going to balance these charges, what am I going to have? This is 1 plus. For me to balance this to be 3, I have to make this to be 3. So I'm going to have another one. I'm going to have another one. What it means overall, I'm going to have 3 now. So I now have 3 potassium here. And already this I have what? 3 minus. And if you add 3 minus 3 plus, is going to give you 0. So what that means is that sodium has to be 3 and phosphorus has to be 1. And this becomes the formula unit of that compound. Now, if you look at the last 2 problems I'm going to be solving here, I brought in some other ones that I had to mention their charges. Now, the transition metals, remember, elements that are in this bracket, we call them a transition. If you can remember that from our chapter 2 or chapter 3. Transition element means they have variable charges. The charges vary. Variable charges. Now, and the only way we can know them is to specify them. If I just say vanadium, I don't know if it is vanadium 2 or vanadium 3 or vanadium 5. That will be confusing. And that's why you see me specify them here. But before we do that, let's do this one. Strontium is in group 2. Group 2 is going to be Sr2 plus. Bromine is in group 7, so it's going to be Br minus. So what it means, if they swap their charges, strontium is going to take 1 here. Is 1, you don't have to put it down. Bromine is going to take 2 from this. This becomes the form. Let's look at this one. Now for this one, vanadium is here, element number 23. It has variable charge, so I have to specify. That's why I did this. And oxygen is 2 minus. So what do I do? Just swap their charges. That will help. And this will go to this. And what do we have? What we simply have is V2O5. And then we go to this one. Now, this is very interesting. Now, this is going to show you that you have to simplify. Now, remember this. For any compound, it has to be the simplest unit. mathematical simplest unit to give you the formula of ionic compound. So let's see what this means in this problem. Now, again, I'm going to transfer these two to chromium. Chromium is going to give this to this. So what do I have? Let's see. It's going to be Cr2, S4. Now, this, if we have covalent compound, this would have been a correct formula. But since this is ionic, if you look at these two numbers, they can cancel. We have to reduce it to simplify it to the smallest. So if you do this, this is going to give you Cr(S2). This is the actual formula of this compound and not this. So if you write this, this becomes wrong. This is the actual formula. So you have to do what? Simplify. You have to simplify. If you have your come in contact with numbers that can easily reduce themselves to the simplest unit. All right, and the last page, but not the least, is also some of those problems I talked about. Manganese 6 plus and oxygen. Again, we always know oxygen is in group 6 and it has to gain 2 electrons. That's what it has to gain, 2 electrons. So I'm going to put 2 minus here. And again, I'm going to swap it. So this 2 is going to go here and this 6 is going to go here. What do I have there? I'm going to have manganese will become Mn, will take the 2 here. Oxygen will take the 6 of manganese. Again, look at that same problem we counted. This can simplify further. So I'm going to divide this by 2 and divide this by 2. It's going to give me manganese now becomes 1 and oxygen now becomes 3. This becomes the actual formula of this compound and not this. And not this at all. Again, the next one. Cobalt. Okay, these two are given. I gave you both of them. So this is going to go to this one. And this guy is going to go to this guy. So what is it going to be? It's going to be cobalt will become 3 and phosphorus will become 2. And this becomes the formula. And the last but not the least problem we're going to do here is gold 3 plus and iodide ion. Let's see what's going to happen. So again, this is going to go to this. And this is going to go to this. And what do we have there? Au will become 1. We don't have to put it. Whereas iodine is going to become 3. And this becomes the formula of this compound. Always feel free in this video to pause and try to practice these problems yourself. And always come back to them. It pays a lot well to practice very well even before you finish this video. And as usual again, if you have any questions, do not forget that the usual channel to contact me is either send me emails or either use the Canvas messages to get back to me. Thank you once again for listening and have a wonderful day and bye.